Good morning, everyone. My name is Yuri and we're going to be doing some shaders today. Let me know if the sound is all right, the visuals are all right, and let's get started. Yeah, meanwhile, I'm going to show you what's going to be the website. Actually, there's been a thing. I've been checking the have to restart all the stuff. I've been checking my old archives with the with my links that I wanted to decompile, and you know what? Half of those links are dead now. I mean, it's been a year or two since I added those URLs to my list, but half of them is dead now. So I've been thinking, I really regret for not decompiling some stuff that I've seen in the past that was pretty awesome. Like this one, for example. This one was one of the 5 URLs at one of the months that I added my links to the queue, and all other 4 are dead. So this is the only one that survived, and I wanted to decompile it while I can. Even though it might be a little bit easier than what we usually do, but still, I find this effect really amazing here. I mean, it's like a water-like effect, and this zoom, it's just cool. Yeah, good morning, and thank you, Ben, for pointing out the sound issue. I was actually speaking to the back of my microphone previous 2 streams, and that's why the sound was not as good as it should be. Hope it's better now. So yeah, let's get started. I'll start by getting my boilerplate, and because I still don't have my laptop, I'm gonna just go ahead and download boilerplate for my Patreon. Luckily, I've added to my Patreon. It's not because I promote my Patreon, but because this is literally the only place that I have it now. It's been almost 4 weeks now fixing my laptop. Alright, so let's get started everything. Hello, buenos dias, доброго ранку, Hiva Humenta, и bom dia. Alright. Let's go to the folder. Let's just run something. Actually, I have another laptop. This one is from 2013, and I have another from 2017, and I've tried to use that one because it's newer one, it's still kind of better one, but I just hate that keyboard. I just hate it. I just can't use it anymore. All right, call this Evener. I can start something. I should see something. Oh, ouch. I'm sorry about the issue. I'm gonna try to make it better. Well, I'm not sure I can fix it right now, but after the stream I will try to. Oh yeah, the screen. Yeah, right. Thank you guys. Keep forgetting about that. Alright. Is it the same as an awards course? What exactly is the same as an awards course? Happy morning, everyone. Alright. So now it's PG screen. This is the website. You can try it yourself. Just do the mouse down and you'll see the effect. Now let's get going. I'm gonna close the windows that I don't really need. Gonna open up my boilerplate. It's running perfectly fine. I would also need to open the actual code using Sublime Text at the moment. I'm gonna move demo to the right. Oh, my fans are going crazy. What? Oh, because the node modules are here, yeah. Probably trying to index all the dependencies in the world now. Yeah, it's almost the same as an awards course. Maybe some slight differences, but still the same thing. Because the one in awards course, I believe, was done a bit later, so it might be newer than this one, or there might be some slight changes, but yeah, it's the same thing. All right. So we have this, we have this. So let's get going. First of all, I'm not even sure if they use three.js. I think they use three.js. Might be. It doesn't really matter at this point if they really use three.js or not. But I have to pay a huge respect to the guys. It's really an awesome effect, and what they did is really amazing. I'll put the link to the developers down there, and they actually have a pretty nice portfolio website as well. So on this website, I think it's pretty old, I should say. It's a couple of years already, so I'm lucky that it's still alive. So let's do it. All right. Respect to Bangladesh as well. All right. Thanks, Yuri. Okay. Where do we start? Okay, so this effect, well, obviously we have some visual on the full screen, and we also have some video. So I'll start by finding the video placeholder. I think the website was called Cover. Yeah, Cover Co. And you can just download something there. So I want something with an ocean because I like oceans. Shutterstock. Something with an ocean. And something with something in the center, like some object in the center, because we're going to be zooming into that one. So maybe this one. They all are slow, but whatever. Let's download this one. And I would also like an image of desert. This one. So it's an image and the whale watching. Okay, whale watching. So this is gonna be our image JPEG, and this is gonna be the video MP4. Really good at naming things now. And the next video is gonna be video 1, and the next image is gonna be image 1. Okay, we get it. Let's move to the JavaScript. So first of all, I need the full screen thing, and there are a couple of ways to achieve that, because right now I have the perspective camera here by default. I have the perspective, where is it? Oh yeah, it's right in front of me. I have the perspective camera. I don't really need that. I mean, I could use it to make a full screen thing, but there's also a commented part about the orthographic camera, which I will just go ahead and uncomment. I think the frustum should be 1 and the aspect ratio is 1. And what it will achieve is that we have the camera has the frustum exactly like minus 0.5 plus 0.5 and the same on the vertical axis. And this means if I have this shape exactly the size 1 by 1, and I do have it 1 by 1 because this is just plain geometry 1 by 1, it should be full screen always. Should always be full screen now. So let's see. Well, not many surprises here. it is actually full screen now. And just to know that it's truly is, I'm gonna import both the image and the video. It's gonna be there's the thing, I don't really need to import the video, because the way that you use the video texture inside the three.js is actually by using the DOM element. So I could use this and then do just video MP4 and then a bunch of things here. What else? Usual place in line. I'm not sure if it's needed here, but still. Let's call it video background. We have it now. So I want to use this video background in my shader. And for this, I will do this video equals video texture. and then like this video DOM element, and so much easier to type on this keyboard than on the 2017 one. Oh my god, feels so good. This is going to be document query selector, and then video background. Hey to Minnesota, I think it's got to be like 2 or 3 a.m. there, right? Crazy, man. Still up. There's got to be the video background, so I have the video as a video texture now, so I can use it in my shader now. You don't really need these types anymore in the shader material now. And you could use just this video, and then I could go to fragment shader, use this video as a sampler, and then I could just do something like this, equals right. Well, nothing works because request video frame callback can't use in operators. What? There's gotta be some dump error here. So the video is before the JavaScript, so it has to see it, and then video dump. Let's just check everything. Null, because this was an ID, right? I have the video. I think I want to play it right away. And I think I need to set the attribute that it should be updated. Video needs. Not yet. Something is still wrong. Boom, 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 boom. Texture bound is not renderable. Okay. Because I'm not outputting anything actually. Yeah. Right. So now we have the video. It's playing in my browser. It's a full screen video. Easy. So the next thing is to fix the aspect ratio of this video, because probably I don't. Yeah, thank you. It should have been an idea, right? So I need to fix the aspect ratio for it. There are a couple of ways to do that, and usually I don't really remember like the one correct way. I just go with something like this. First of all, I need the screen aspect ratio here. It's gonna be right. I have it. So now I have this one as a uniform. Now I could scale my UVs, which I actually have commented in my template already. So instead the resolution, I'm gonna put something else. So I have just the width and the height of my screen, and I should probably do something like this. So this is the scaling of my UVs, and I would be using UUVs then, and I should scale it in some way. And you know, I don't remember how to do that, but there's like a finite amount of steps. Finite. It is a finite amount of steps. Oh crap. To achieve this effect, to achieve the correct computation. So first of all, I'm going to multiply it with something like this. And you know what? The viewport right now is actually like almost square. What I also need is the aspect ratio of my image, of my video. And the aspect ratio of the video is what? Full HD? Yeah. So I'm gonna do the video aspect equals and then the screen aspect equals this. And then I'm gonna have the like multiplier equals by default is just 1, and then if you could do it in JavaScript as well, so just and here I will multiply with this multiplier. Oh, South Africa, that's crazy. So depending on which aspect ratio is bigger, the screen or the video, I should multiply it with a different coefficient here. Not these, but just gonna update the multiplier here. It's gonna be 2 and then 1, and then one of them divided by the second one, or the other way, we would see now. So yeah, this way you achieve the like background size contain thing. What I need is a background size cover thing, and for this I would just do it this way. Strong, but then I should like inverse this one. And here we go. This is the background size cover implemented in glsl. And for the other aspect ratio, you just need to inverse that one. We wouldn't really need that because I'm gonna stay with the same screen, but just keep that in mind. Right, so this is how you achieve the background size cover in glsl. Of course, those should be updated on the resize, and you should put them as a uniforms, not as a hard-coded values, but whatever. We got it. Next, I have this. I also wanted to implement the desert here, which I had there in my image. So here, image, and then there's going to be image here. And just to simplify things, I wanted the image to be the same size as the video. I'm not sure if they are. Oh, it's too big. Gotta fix that. Boom, boom, boom. Gotta fix that real fast. And this is gonna be my desert. It's better to scale images like this. If you will try to use them in your WebGL, the image like 4K, it's gonna take a lot of resources, especially on mobile. What I'm trying to do here is to go to the Avener and then update my image. Did it really update? Still 1 megabyte. Okay, I'm just gonna save it to the desktop. Here we are. Yeah, now it's correct one. Now let's see if it's working correctly with my UVs. It's gonna be U image, and we should probably see the image now correctly scaled. Right, so we have the image, we have the video. Now we have to make this transition, because let's say that this is a desert and this is the video that I want to show with an ocean. So I want to put an ocean over the desert. First of all, let's do this circle thing. So first of all, I need to create this circle. This new UV, and this is going to be the video. Let's just put both of them, and then the let's try to call it an image. It should work. And then an image. Yeah, it's working. All right, next circle, creating the circle. Let's kind of want to create the function for the circle, even though I could just write down the hard-coded thing here. Yeah, I'm sorry, I can't speed up. So there's going to be some pauses here and there. I want to create the function that creates the circle. And this function should just calculate the distance from the center of the screen. So I want let's first calculate some circle UV, which are going to be like the UVs that are scaled for the circle. And to calculate the distance from the center, I first need to do something like this. So then if I just float distance or length, just output this thing here. Bottom. Why don't I see anything? 118. Oh, of course, yeah. It should be vector 4. Greetings to France too. So now we have the distance from the center. It's obviously 0 at the center, and that's why it's black at the center. But then it gets bigger when you get to the edge of the screen. So I want the function which gets me the circle, but which is more like sort of could do like this. For example, it's to create a circle, just make a smooth step. I don't want a function to just make it easier. And the guys use the function, so I kind of want to recreate this function. So it's going to be the circle function, which is going to accept first the UVs, some UVs here, second the radius of the circle, and what else do we need? We need the sharpness, because like this value is the sharpness. Oh yeah, I started to create the function. Okay, radius float sharp, and then I can calculate something in here. So that's also an equivalent to calculating length is just to calculating the dot product of the vector with itself. It's going to be the same as the length of the vector, because there's going to be two coordinates of the vector squared. So for this, I will first normalize my UVs. So it's going to be like vec2 temp UV equals UV minus. And then I have to return something of this sort, which accounts for the sharpness and for the radius. It's going to be smooth step. And then inside this smooth step, there's going to be the length of the vector. Although there's another way, as I said, I want to try the different ways. It's going to be the temp UV squared. And then here we should have two values. So first of all, it's going to be radius, and then radius plus or minus something. So first of all, I'm gonna do the radius minus radius multiplied with sharp, and here I'll do the same with the plus. So this way we would have the sharpness for our circle. This should actually already do something for us. So we have the float, so instead of calculating this smooth step, I'm gonna run the circle on VUV, and then the radius, let's say 0.3, and then the sharpness, like real small sharpness, so it's gonna be sharp. Nothing working because probably some glsl error again. Smooth step. I did something wrong with the smooth step. By the way, this value is going to be between 0 and 0.25, like a quarter of 1. So I should probably multiply it with some value to normalize it back to 1. And then what else is wrong here? The value should be a float one. Yeah, that's the first mistake. And then 109. Yeah, I should probably put this here. All right, so now we have the circle. Now let's make the circle like dependent on some value that we output from the JavaScript. So I'm gonna do another uniform. I'm gonna put circle scale here because this is a radius, and then I'm gonna boom boom boom. I want it to be white at the center, and then let's add this uniform here. So first use circle scale, let's say 0.5. Then I have the settings template here. Let's call it scale. By default 0.5, and then I have to set it. That is not defined. Let's wait until it installs all the depths for us. Okay, something is still wrong. So we have the scale is being updated. It updates, oh no, we have to update the value. Made this mistake hundreds times. Still something is wrong. Value of undefined. Uniforms. Yeah, so now we have the scale. Changes, you can see it changes pretty fast. So when we go to 1, it's already past the screen size, and that's why I needed to normalize the thing, I believe. Just multiply it with 4. So now it roughly is the size of the screen. Maybe I could also change the scale not to 1, but actually to 2 is the way to go. If I set the maximum value 2, it's gonna be the right one. It's exactly. Yeah, now you could see the circle is getting bigger and filling the whole screen. Perfect. So we now created the simple black and white circle, and what I could do right away, I could actually mix two of them together. So I could now do this. I could now do the like for final equals mix in video and the image with the, this is not actually distance anymore, but let's keep it for now, and then just gonna output the final. Oh, just the final. So what you could achieve with this is just this circular mask, which you could actually achieve with the SVG and even with CSS, I believe. So it's not that complicated. I also remove the progress. I think I don't really need it. Right, next we gotta make that it's not, obviously that's not everything that we need to do here. And by the way, I think it's the other way around. I wanted the ocean to fill my desert, not the other way. Right. Okay, so now we have to make the distortion part. How do you do that? Well, first of all, the circle, is it actually the circle? Not sure about that. If we just resize it, it's not really the circle. So to make it a circular thing, we have to multiply this circle UV with something, and that should be the screen aspect ratio, and this is where we need the screen aspect. It's not like this, so we have to normalize it back again, I guess. Yeah, and then I think it's gotta be not multiplication, but this. No, still not like that. So it's gonna be screen aspect. It's gonna be the same because I'm multiplying two-dimensional vector with a float value, and it's gotta be something like this. Yeah, this should work, or maybe not. What the hell? Why doesn't it work for me? It should be working like this. So I should change the aspect ratio. So let's say I'm gonna multiply it with 2. 20. Doesn't change much to me. It changes something weird for me. Dun 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 dun. Just change some variable names so I'm not messed up in the future. I'm gonna change it to circle progress. So when the progress changes, we change these values. Then I see the circle scale, and probably I should change this value as well to something else. Like, what was the good value for that? So I'm normalizing the circle UVs here. So I should get the perfect circle for any kind of screen. It's not really important because I could make a square browser window now, but it's just the principal thing. I need to fix it. I need to fix it now. It should be the screen aspect ratio here. Some reason it stops working for me. Why it's not circular? Do you have any idea? What the hell are you? I have no idea. That's the question I've been asking myself my whole life. Okay, let's make it one by one. It's not really important because I can make it like this, and we can maybe return to this issue back again. So that's the way to normalize it, and this is the way to normalize it. I'm not sure where I messed up. Using the circle UVs, and then subtracting 0.5 here back again. Circle size should be fine. Should be fine. Yeah, well, I could actually use it because these ones should be, but the UV are normalized also for the image size, not only for the screen size. And this circle progress only needs to be normalized for the screen size because it doesn't have to do anything with the texture actually. Because if I do it like this, it's gonna have the texture dimensions in here. So new UV is not the way to go. I'm gonna fix it later. So it's circular anyway. Then I don't need this sharp border here, so I think I could also put the uCircle size here as well. And we immediately get this effect. So when it gets bigger, it's more blurred. So it's actually kind of nice by itself, this effect. I think I gotta make it a bit less of a something like this, so it doesn't change as much, doesn't blur as much. It's only made it worse. So not here, but here. So just to make it a quarter of like sharpness. So when it gets to the border, it's still not as like completely blurred. So and when it starts real sharp, and then it gets blurred. So that's where you get the nice effect. It just feels much better than doing the same. Like I could actually use the static value here, but it's not gonna be as nice. Gonna be too predictive for the user. Right, and this value actually is already dependent on the circle radius because I have put it here. So if I only did this, and then did this, it will be the same throughout the whole animation. You see, it starts even blurred this was the way. But because I've put it already here, it depends on the actual radius. So the bigger the radius is, it's kind of relative to the radius. Like because of this sharpness multiplied by the radius, it's relative to the radius already. But then I make it even more relative because I make the whole sharpness thing again dependent on the radius. So I think it's just the same as you apply the easing to the actual animation. You might replicate the same effect, but it still feels good. All right, so we have this. This is obviously not it because we have like cool thing here. I'm gonna implement the mouse animation as well. So the next thing I want to do, I want to make this distortion. This is the most interesting part, and it's actually not that hard to do, but I just like how it is implemented. So we have the circle progress. First of all, to make distortion like this from the center, I need some vector pointing from the center. So I'm gonna do the, that's called center vector. And it's gonna be just VV minus 0.5. This is gonna be just the vector pointing from the middle of the screen. Just to visualize that. Yeah, so this is almost like the UVs, but we have the black part because the vector is pointing to the negative space in that part of the screen. Right, so now what else I need to do? I need to use some noise functions. To create this animation, I would need some noise. Just copy paste the noise functions. I think you could use any noise functions, but just to like replicate the exact effect, I'm gonna put the functions that the guys used on the website, my fragment shader. Let's run through them. So there are a couple of functions, like first the noise function. There's also random, which is used by the noise and the other functions, I believe. And there's a function from the glsl website, and there's FBM and FBM low functions. So let's see what they do. They take the value that they take is actually two-dimensional vector, and they return something one-dimensional. So I'm gonna do it like this, and then FBM VUV. Let's see what's gonna happen. So we have this noise. If I multiply my VUV with, like, say 100, we would see this weird noise. It's not really useful for like every single case, but it's still kind of nice. This is how the noise looks like. And why is it? Oh, and it's working with the time because I already put the time inside this noise. All right, so there's also FBM low noise, which is just the static noise of the same kind. Maybe it's different amplitude. No, I think the amplitude is even the same. It's just the same noise, which is static and like the same picture. All right, scale doesn't do anything now. So we have this noise. How do we do those ripples with the noise? How do we do that? For that, we will need to calculate some value, some distortion for our UVs. So the UVs that we are using at the moment are new UV. And I need to put some distortion in there. All right, how do you put the distortion in there? So first of all, I will calculate another set of UVs, which is going to be used by my frame buffer, like not frame buffer, but fractal browning, what's that, motion noise. All right. I need to calculate the new noise UV. So let's ripples and ripples. Let's calculate ripples. First, noise UV. Noise UV is going. I need to normalize noise UV again, the same way that I normalized my new UV. So it's going to be just new UV multiplied, not multiplied, but subtracted the half of the. So this is the centroid UVs. So we again have the centroid UVs. You need to debug every single step. Something is wrong now, because why? New UV undeclared identifier, because I calculate new UVs too late. So yeah, so we have the noise UVs. It's kind of the same thing. It's just keep viewing. All right, so we have the noise UVs. Now I kind of need the time. Well, I already have the time. So what else do I need? I think I could already calculate something now. So let's call it a swirl. And the nice thing that you could use about those noises, like you saw that noise doesn't really look like ripples, so doesn't really look interesting. But what you could do, you could take the noise from the noise function. Like you could use the FBM function, and then you have to put noise UV here, which we could multiply with another noise function. So we could just multiply with the FBM low, and then just to approach the something close to what we actually need, I'm gonna put, okay, just the VUV here for now. And let's see what swirl is gonna look like. Doesn't look like anything because noise UV undeclared identifier knows UV, okay? So now it's black, doesn't see anything, doesn't see much there. Maybe the values just are small there. Yeah, so they are just quite small. So now we have the different noise. It looks completely different. What we could do again here, that it's instead of using the actual noise UVs, what if we would use the length of the noise UVs? And then because it accepts the two-dimensional vector, I have to wrap it in the two-dimensional thing again. Let's not multiply it by 20. So now we have kind of, okay, I could maybe multiply this with 10. So we have something circular, maybe divide this with 10 to make it more, to have more, I kind of want to have more circles here. For some reason I don't really have, because I need to add the time here as well. Right. So what I wanted to show you is actually this FBM function could return us already some circular things just because we, maybe this one is going to be more circular, yeah, just because we put something as a length from the center, and because this value is the same, we have the like perfect symmetry with the noise. It's still a noise, but it's perfectly symmetrical. I believe if you put the time here, we would change it. So what I want to do here, I want to put something else inside this my FBM function, something better. First of all, I'm going to put new noise UV, then I'm going to multiply it with my FBM low function, and this FBM function will be using the length from the, like the distance from the center. The length of the vector is just the distance from the center, and then I could add something here. This have to be two-dimensional thing, so this is a float value, so I have to add something like two-dimensional here as well. So first of all, I need to add the time, just so the time is running, and let's see something change. There's an error because this gotta be two-dimensional thing, and then they actually added some weird values. So I could just wrap this one into this, and we're gonna have some kind of ripples because the time is running way too fast here, and probably the other way. Like it's just the same, I just put the time to my ripples now, and I'm taking the FBM function twice now, but the time is running way too fast. So now we have kind of ripples. Just to make them more dense, actually added this weird value, and this is probably to normalize this noise UV thing, because it just you could see that in the center or like not in the center, but on the edges, we have a lot of gaps here. It's not really normalized. So they actually have this weird value, which we're gonna kind of interested how they came up with this. Probably just one of the ways to normalize things, but still. So they used this value, length from the noise UV, multiplied by 10, multiplied by noise UV, and then multiplied by 20. So this is something, right? They call it RV, so probably just some rotational thing, or I don't know, normalizing thing, and they just put it here. UV, probably some brackets thing here. It's noise view. Okay, what's the error? What's the error that I have? 96. Oh yeah. You couldn't see it right away, but the ripples just look a bit better. I'm not sure, we're gonna test it maybe later on. I'm not sure even if it makes it much better, because you could still get the ripple effect. Alright, so now we have to implement this ripple effect into our distortion. How do you do that? Well, first of all, I'm gonna convert this swirl value to the two-dimensional value to distort things. I'm gonna do it like swirl distort equals what I could do here to make it even better, I could take another FBM noise function from this. So I'm gonna call FBM low, again from this noise UV multiplied by swirl. And because I need two-dimensional thing, I need to multiply this float value with something two-dimensional. So I'm gonna multiply it with my distance from the center, like from the center vector. Because this way I could add this value to my UVs, like the UVs that I'm using there, and it will scale my UVs. So I could add it to my new UV, and it's going to be a distortion. I have no idea why YouTube suggested it to you. I'm just live coding here. This is weird. All right, so noise UV length. I'm doing some glsl programming here. Center vector. So let's output this swirl distortion thing. It's gotta be something. It's probably very small because you could see the distortion waves and ripple waves now. But I have to probably multiply it with some big value again just to see it. So this is my swirl distortion, and maybe I could multiply it with, let's say, 10. Yes, now you could see it's somewhat like UVs, and it should distort my UVs now. So I could bring back my image actually right now. I could bring back my image, and I could add this value to my new UVs. So new UVs is going to be plus equals swirl distort, just swirl distort, all right. And then I could bring back both of those so now we have this amazing thing. So we already have those ripples. We could actually make them even better than that. It looks weird on the inside shape, but on the outside as well. So I believe it's just way too big. I think we could just multiply this one with like 0.3. And now just have some more realistic ripples coming from the center of the screen. Right we go. Perfect. So now we have to implement like this whole animation using those ripples again. And I believe we should only use the ripples on the outside image, like on the background, because they should only be on the outside. So for the inside shape, I have to calculate another set of UVs, and let's call them like two inside UV. And for that one, It should scale a little bit, and it should use just another set of UVs without the... So maybe just let's do it this way, like background UV. Just gonna add that in there. And for desert, I'm gonna use the background UVs. Oh, the wrong one. So it's background UV. Gotta be like this. Now we only have waves on the background shape. Getting close to the final animation. So you could see it's almost there. We just have to fix the edge. I think the edge is a bit wrong here. And for the edge, we need to have some distortion, because I think on the edge there's another set of distortion there. It's like it's not really like the gradient fade from one to another. It's actually a distorted shape. How do we do that? Hey, I'm glad you came here. So we wrote a lot of scaling multiplication glsl now, and it's getting complicated in my head now. We are close, but we have to calculate something more. All right. So let's calculate inside UVs again. I still need it, I think. It's gonna be 2 dimensions, and then I will need to add something in here. It's gonna be like new UVX, UVY, but something more in there. So I have to add something dependent on the circle scale, on my circle progress, actually. And it should also scale my whole vector, I believe. It should scale my whole vector. I'm a bit stuck here. Forgot the next step. What's better to do? Because I do prepare for the streams, but sometimes I pick the random path, and then I have to figure out how to bring back the good explanation to what I'm gonna do next. Ask YouTube about that. Why are you asking me? I have no idea. All right. How do we go about that? I think I could also do this like this. So if I multiply something with the center vector and the circle progress, it should scale the image. Probably. Let's see. Center vector I have, circle progress I don't. Should put it here. $209. Yeah. So now I could see that we have this distortion on the edge of the, so it looks better with this, but this is not the scale that I wanted to implement. To implement the scale, I actually need to add another value. So I have to add like center vector multiplied by the circle scale, by the scale of this, the more the circle is, the bigger the image is gonna be. So it's gonna scale the image. Or it would just, I think I should subtract this. Okay, I should probably remove the ripples for a moment just to see where do I have the ripples. Ripples. So you could see when I scale, the background image is getting bigger as well. This is what I wanted to achieve, kind of a ripple effect. So the ripples go and the like inside shape is kind of gets from the center of the screen and pushes the other pixels far. What I could do here is actually maybe make it less of an effect. It's too much. Yeah, you could see now that when the inside shape is getting bigger, the outside shape is just scaling. So now I could bring back the ripples here. And we are almost there actually. So maybe not to subtract this, but to add this value. Let's see how it's going to look like. So sometimes it's about the experimenting thing. So if I don't subtract this, you get this effect. But if I subtract this one, you get kind of nicer effect of a distortion, like it's getting real from the inside. Because I think it inverts the UVs on the edge of this circle, and that's why we're getting this kind of weird distortion, like a black hole thing, I think. Something like this. I think it's almost there. The other thing that they also added, and I'm not sure if it's going to change the visual much, but let's just do that. So right before they calculating the UVs for the noise, they actually added the rotation part. So they did this, and already have the rotation, like two-dimensional rotation matrix here. So I could just, oh crap. So I could just go boom to my shader. Where was I? Noise UV. And I could multiply my noise UV with some rotational things, which gonna be like rotating my system of coordinates. And let's see what's gonna happen there. It's gonna be time and maybe some coefficient. I don't know, just to rotate slowly. So right now we kind of should have the noise UVs. Let's just output the noise UV. I missed this step because it already looked nice. Why is it like that? $231. Oh, it's again. Okay, so we have this, but it should actually rotate. Maybe just multiply it by 10. Yeah, so it's actually rotating. So when we multiply it with the matrix, and because it's normalized already, just rotating around the center. So if I just rotate it, it means that all the ripples will be rotating as well. So it's going to be like rotating crazy thing here. So I just remove this. We just get the crazy ripples because it's going to be like more random, more nature-like. And the funny thing that they also added, they rotated it backwards. Like after calculating this RV, they actually rotated it backwards at some point. Oh no. Right before they again throw distortion, because we use the noise UV here again. So these are going to be different noise UVs. So this noise UV is rotated, which we are using in the swirl calculation, and then when we take another FBM low function, I'm going to just rotate it backwards, like maybe with another speed, something like this. So this way it just looks more random. This is the only thing that it changes. We could change some values here now and see whether this RV actually changes something. I'm not sure. Maybe just adding to the whole visual. Not really sure this RV is adding something. I wonder like what was the reason of adding it. I believe it's normalizing things, but not sure in which way. Why is it better? Because I decompiled the sources, they had it, but I'm not sure why. So this is the effect, and what they did, like on the mouse down, they just animated to one value, and then on the mouse up, they animated backwards. But this is the effect you have here. It's pretty awesome, actually. The video is not really an action movie, so it's hard to see it's a video. Probably could have get away with an image. But this is how you make it. I mean, it's pretty complicated. You have to experiment a lot with the values, because, well, even in my stream, I had some like back and forth things, like whether I should take another FBM noise function or not. Maybe you could take another one and ripples is going to be even better than that. Maybe not. Maybe you could multiply this with, let's say, 100. It's going to be a different story. Not that much of a different story, to be honest, because we still take another FBM noise function there. So maybe I should multiply this one with, say, 20. Yeah, the ripples become much bigger, I think. It's going to be just 3. It's just small ripples. So depending on what you want to achieve, you could play with this noise function. And of course, I think you would achieve the same thing within any noise function. It's just with this function, they probably achieved the one that they liked, really. Yeah. So this is it for today. I think this is enough. It's been an hour, and I tried to make a good job at explaining you this effect. And this is pretty much the effect that we're using here. I think they also added the fisheye function, the distortion of the inside shape even more, but it's not really that visible here because the effect is so fast, so you can't really see it there. Maybe just a little bit of the scaling for the inside shape as well. Let's just add a little bit of the scaling there too. It was the inside U. Which UVs I'm using now? Background and UUV. I'm using new UV. So I could just, yeah, these are the inside UVs. Okay, so I'm gonna update them. And what I could add here is just the other way that I did to the background UV. So instead of this, I could actually do it this, it's gonna be UV. Let's see what's gonna happen. You could see it zooming in, but I should do something like this. Now it's zooming the other way around, so I should probably add this value, not subtract it. Now it's zooming way too much, so it's 1, 1. It should be just 1. And this is how you do it. This is of course, you should calculate more correctly the actual scale value, because you can see the texture bleeding here. So it's probably shouldn't be like this value should change a little less than that. But if it's animating real fast, no one would probably notice this effect. You could also just mirror everything. So do like something inside UVs equals fract inside UV. Well, it's not really the mirroring that I expected, but it could also work. And then let's bring back the ripples. I like the big ripples more. Where did we have it? Like here, 15, let's say. Yeah, like more ripples. This is how you do it. Not even sure the actual rotation added something to the visual. Like it depends on the feeling that you want to achieve. You want to be adding some small details that feels good. Right. So this is it. Hope you liked it. I will try to continue streaming every Sunday. Yeah, it's just G-sub animation outside the shader, and you just animate it back, and then mouse down, you just animate it down to 0 again. Just gonna read the comments. No, I haven't done the FBM stream, but I believe the Inigo Kill has done those on video, so you should check out his channel and his website. He has done a lot of work in that. And this actual noise is actually linking back to his website right here. And we could go there and see the explanation of how he achieved like this realistic noise function. And there's a little bit of math, of course, but it's actually, there's also an example how to use it. Yeah. Can you add trigger on click? Okay, let's just add trigger on click real fast. Let's just add it. So I'm gonna be animating circle scale, right? What is it? I need to animate this settings scale. All right, I'm gonna add the mouse events. If you have some question, ask me. I'm gonna spend a couple of, I have probably 2 minutes coding this, and then set this up. And then let's go to scale to 2. Well, here you go. I should probably also add another uniform for the waves, so I should also enable waves and ripples only when the whole animation works. And maybe it's just slower. Maybe it should animate back faster than it animates towards the actual animation. Oh, actually changed the did something weird. Yeah, so this is pretty much how it works. You gotta animate, of course, more values, but this is it. Oh, 4 AM, that's crazy, man. So guys, thank you everybody for watching my streams. Thank you everybody for supporting me. It's been great support on Patreon so far, and I'm really happy with it. I will try to continue streaming. Okay, I can also try this. Can I try this? Just some bonus content if you're still watching my stream. It's been issues with the lighting as well. Alright guys, so thank you. I wish you a good day, good Sunday. Say some kind words to the people you love. Don't forget to call your parents or the people that you love and say them something good. And let me know if you had some fun with the code that I just coded. Maybe you had some other experiments. And also a huge respect to the developers of the website. It's really cool one. So thank you everybody and have a good Sunday. I'm gonna stick in the chat for a couple of minutes and